All right, welcome. Today we're going to crack the code on a classic calculus problem. You know the one. It looks pretty innocent, but it has a really clever trick hiding inside, finding the integral of cosine squared of x. If this one has ever tripped you up, you are definitely in the right place. Okay, let's get into it.
So why is this integral such a pain for so many of us? Well, it lives in this weird, tricky space. It's not quite a basic problem, but it's not super advanced either. It just requires you to think a little bit outside the box.
And this is what's so interesting, right? If you just integrate a simple cosine of x, that's calculus 101. It's one of the first things you learn. But the second you add that little squared symbol, boom, the entire game changes. Your basic rules just don't work anymore, and you can't solve it directly. We need a whole new strategy.
To solve this puzzle, we actually need to take a little detour. We're going to step out of the world of calculus for a second and jump over to trigonometry. Think of it like this. We're about to forge a special key that's going to completely transform this problem for us.
And here's our starting point. This is the raw material we're going to use to make our key. It's the double angle identity for cosine. This is a big one from trig, right? It says that the cosine of 2x is equal to cosine squared of x minus sine squared of x. This is where it all begins.
So let's see how this key is actually made. We start with an old friend, the Pythagorean identity. Then we just do a little algebra to get sine squared x by itself. Now, and this is the really clever move. We substitute that into our double angle formula. After we clean it up a little, we're left with a direct link between cosine of 2x and cosine squared of x.
Okay, with one final algebraic shuffle, we get cosine squared of x all by itself. And this formula right here, this is the secret key we've been searching for. This is what lets us swap our difficult problem for something way, way more manageable. And now for the big moment. We've got our key, and it's time to use it to unlock that original integral. This is where everything clicks into place. So here it is, one last time. The locked box. The problem in its original form that we couldn't solve. Remember, we just can't integrate this thing directly. But now, watch this. With our key, we do the substitution, and just like that, it's unlocked. We've turned the integral of cosine squared x into the integral of 1 plus cosine of 2x, all divided by 2. And this is a problem we can absolutely solve. Now that we've transformed the problem, the hard part is over. All that's left is to actually do the integration. So let's break down these final steps and get our answer. First things first, let's make our lives a little easier. That divided by 2 is just a constant 1/2. Let's pull it out front so it's out of the way. Then we can use the sum rule for integrals to split this one big problem into two smaller, much simpler ones, the integral of 1 and the integral of cosine of 2x. Now we just knock them down. The integral of 1, that's just x. Easy. The integral of cosine of 2x is a standard one that gives us 1/2 sine of 2x. Now we just put those two pieces back together inside the brackets, and we get this expression right here. We are on the home stretch. We're just going to distribute that constant we pulled out, add one final piece to the puzzle, and we will have our complete solution. Okay, so we just distribute that 1/2 that's been waiting out front. That gives us our final answer, x over 2 plus sine of 2x over 4. And of course, because it's an indefinite integral, we can't forget to add our constant of integration, the good old plus c. And there it is. That's our answer. But how do we know for sure that we're right? Well, we can check our work by going backwards. If we differentiate our answer, and yeah, you got to remember the chain rule for that sine term, we end up with 1/2 plus 1/2 cosine of 2x. Now, if we use our key in reverse, that simplifies right back to where we started, cosine squared of x. It works out perfectly. You know, what this whole process really proves is that sometimes the hardest part of a problem isn't the calculus itself, but knowing you need to grab a tool from a completely different area of math. So the big takeaway is really a question for you to think about. The next time you get stuck on something, ask yourself, what other problems could be solved by looking for a key in an unexpected place?